Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a critique of NASA's 10 rules for software development, a set of guidelines famously stringent in their pursuit of reliability. It's a fascinating discussion.
Absolutely. I've read the rules myself, and they seem incredibly restrictive. The author of this critique, however, argues from a different perspective, focusing on language processors and application software, not embedded systems for spacecraft. Right?
Precisely. The core argument hinges on context. NASA's rules, designed for mission-critical embedded systems where failure is catastrophic, prioritize verifiable termination and predictable memory usage. But these constraints might stifle creativity and efficiency in other domains. I see what you mean.
Exactly. The critique highlights the absurdity of applying these rules blindly. Take Rule 1, restricting control flow. While eliminating goto and recursion guarantees termination in theory, the author provides a nested loop example that would take longer than the age of the universe to complete. Hilarious.
Right. The practical difference between will terminate eventually and will never terminate in a human timescale is negligible in most applications, and forcing a recursive solution into an iterative one often leads to less readable, more error-prone code. Interesting.
And Rule 3, banning dynamic memory allocation after initialization? The author cleverly points out that while using a custom memory pool technically satisfies the rule, it doesn't address the underlying concern of memory management. It just shifts the problem. It's a clever point.
It's a great example of how focusing on the letter of the law rather than the spirit can be counterproductive. The author advocates for using a memory allocator with known behavior and proving bounded memory usage, a far more robust approach. I agree.
Rule 4, limiting function length to a single page of code, is another example of a rule that's outdated and arguably irrelevant in a modern context. Screen real estate is far more flexible than paper, and the real issue is code complexity, not line count. Right?
Exactly. The author suggests focusing on the cognitive load of a code block, not its physical size. And the discussion of nested procedures and folding editors highlights the limitations of a purely line-based metric. Got it.
The critique also challenges Rule 9, the restriction on pointers. The author argues that limiting pointer dereferencing and banning function pointers severely hinders the use of abstract data types and higher-order functions, crucial tools for managing complexity in many programming paradigms. It's a strong point.
Absolutely. The example of simulating function pointers through enums and switch statements demonstrates how adhering to the rule leads to less elegant, less maintainable code. It's a compelling argument against overly restrictive rules. I see what you mean.
Overall, the critique isn't about dismissing NASA's rules entirely. It's about emphasizing the importance of context and critical thinking. Blindly following rules without understanding their rationale and adapting them to your specific context can be detrimental. It's a great point.
Precisely. The author concludes by highlighting the value of Rule 10 compiling with all warnings enabled and using static analysis tools, but argues that some of the other rules actively hinder the benefits of these tools. It's a nuanced and thought-provoking analysis. Interesting. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this discussion. Goodbye.
Bye-bye.